So to start us off with in Math 201, we look at some problem-solving strategies. These are commonly considered word problems, so I know they're not everyone's favorite, but that is how we start off. We'll get into more math topics that were directly related to your majors as we go through. In Chapter 3, we'll get to methods for adding and subtracting and multiplying and dividing, but for now we're going to, like I said, start with problem solving and what a lot of times people call word problems. So our textbook lays out 4 steps for these word problems, and these steps are to help you through the process because sometimes it can be kind of daunting figuring out what you need to do. So these are our 4 steps. So the first one they say to do is you need to really understand the problem. And I like to say that means that, hey, maybe you need to reread the problem a couple of times. That's one way that we can understand it. This is where you might underline, highlight, circle keywords. That would help you as you go along. So maybe some numbers that stand out, some of those key math words. Second thing we need to do is devise a plan. So this is, what are you going to do? Mathematically, what do you think you need to do? There's only so many things we can do in math, right? We think about our 4 basic operations being adding, subtracting, multiplying, and dividing. So if you had to pick one, choose one. What should we do right here? Or we're going to see in some of these problems that we're going to work in this section, we might want to like draw a picture. That's again, devising a plan. Just come up with something that you're going to want to do. If you don't do this, this is where the step where people kind of stop. You're never going to get it right if you don't just devise some plan. It doesn't have to be correct, but it has to be a plan. Just get started. Next is to carry out the plan. And this is my way I say do something. Again, you don't have to feel super confident in it, but a lot of times if you do something, even if it's wrong, you might say, oh, wait, well, I know this isn't right. Let me try something else. It gets the wheels go on. So write something on your paper. Even, like I said, even if you're not confident, writing something down is better than writing nothing. The answer's not going to come on the paper itself. So you have to start by putting the pencil to the paper. And lastly is to look back. So just ask yourself, does this make sense? Does the answer make sense? If I ask you like how many cookies somebody made and you got an answer of -10, when you look back, you'll be like, there's no way that's the right answer. You know, sometimes there's a feel like this answer feels too big or too small. So just think back, does this problem make sense? All right, we're going to put this into context in some of these problems that we're going to do. So this first one, there's not a lot of work to show for it. As we go on with the other problems in this chapter, there will be work to do with them. And I promise I'll show work anytime that I can. So in problem number 1 here, Anna, Spencer, Josh, and Elizabeth are in a race. Anna is the quickest. So that means she's going to be in first place because it says Anna is the quickest. Josh is faster than Spencer. So I know that somewhere Josh is going to be before Spencer. So Josh is faster than Spencer, but slower than Elizabeth. So Josh is slower than Elizabeth. And that's the order. I did the order right as I was reading through. As you see, I kind of crossed out as I used something that kind of told me, I've already done that, let me go to the next, kind of gave me my organization or my plan in that particular problem. These next 2 go hand in hand, and there's a couple different ways to set these up, but is a very pattern-oriented system. There's a set way that we can work these every single time if we know steps. And as we're going forward, the next section in this chapter 1, is patterns. So this kind of sets us up for it. So I'm going to work it very patterny. You might see this set up differently other times. These patterns are going to work all the time. I just have to choose one way to present it. Gauss was a mathematician that was pretty famous. He did lots of other things, but this is called Gauss's Sum because he kind of really, I guess, made this very popularized this system used to add up numbers. So we want to know the sum of the first 100 natural numbers. to make sure we're all on the same page with natural numbers. Those are the numbers that start with 1 and go all the way to infinity. No negatives, no decimals, no fractions, no 0. They're called the natural numbers because they're what we're naturally born understanding. So these are the first numbers that we teach children. We can teach them to count like 1 to 10. For instance, we don't teach them decimals when they're 2 and 3 years old. And sum means that we're going to be adding. So I'm going to add together these first 100 natural numbers. I do not actually want to add those together in my calculator. There's no way I would do that correctly without messing up. So I'm going to use this system that Gauss came up with. I'm going to call this S for the sum. So that's the way I'm going to list out the first 100 natural numbers. I don't want to list out every single number. That would take forever. So I put that ellipse in the middle. The dot, dot, dot just means all those numbers in between. So for instance, the number 27 is in that list. I didn't want to write it, so I just wrote a couple at the beginning and a couple at the end. Now I'm going to write that same sum backwards, like we were counting down from a rocket taking off. My highest number is 100 and my lowest number is 1. Those need to line up. The highest and lowest are going to go together. So I'm going to start at 100 and I'm going to count down. You can use as many as you want. So if you want to put that 97, you don't have to. If you don't like that 4 there, you don't have to do that either. But I'm going to line it up. I can change the order because the order for addition doesn't matter. We say it's commutative. 2 plus 3 is the same thing as 3 plus 2. I can change the order. So that's all I did was put this increasing and then decreasing. Now I'm going to do a little bit of algebra. I'm going to add down the columns. Let me show you what I mean by columns. So here's a column right here. S plus S is 2S. 100 plus 1 is 101. 2 plus 99 is 101. Oops, that's a plus. 3 plus 98 is 101. In fact, every one of these columns is going to be 101. It doesn't matter how many numbers you want to put in there. You know, you can put 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5 when you're setting it. Does not matter, but every column is going to be 101. And it has to work that way. If it doesn't work that way, you didn't set up those two sums correctly. So they always are going to work out to be 101. So that is a whole bunch of 101s. In fact, it is 100 of those. This is the number of terms. Whenever I have a whole bunch of adding together, that can be turned into multiplication. Multiplication is in fact repeated addition. For instance, if I had 2 plus 2 plus 2 plus 2 plus 2, that's a lot to write out, so I could just say 2 times 5. I don't want to write out all those 101s. I know I didn't want to write it out. That's why I have the ellipse right there. So instead of writing them all out, writing out 100 of them, I'm just going to multiply 101 times 100. I'm going to keep going, multiplying 101 times 100, so just doing that multiplication step. I'm going to divide by 2. I'm doing a little bit of algebra here to solve. So the answer is 5,050.